Okay, so let's recall back from chapter 1. What is this statement called? If P, then Q. We call this a, anybody remember? I would call this a conditional statement. Remember that? And actually, this is wrong. Give me a second. It should be Q sorry about that. I changed it earlier and then forgot to save it. So if P, then Q is conditional. What if we have not Q, then not P? Excellent. We call that a contrapositive. Okay, now I just screwed all of it up. Sorry, guys. Okay, so when we had a discussion about this in chapter 1, I'll fix that later. We had a discussion about this in chapter 1. What can we say about both of these statements? So let's put this in some type of scenario. So what if, this was my scenario earlier this morning, if you come to school late, then you will be marked tardy. Is that true? If you come to school late, then you will be marked tardy is a true statement in my class. So what would be the contrapositive of that? If you do not come to school late, then you will not be tardy. Is that true? Does anybody remember what we talked about with conditional and contrapositive statements? If one is true, this one's true. If this one's false, this one's also false. What were the other two statements? The inverse and the converse. Good, guys. The inverse and converse have a relationship, and the conditional and the contrapositive have a relationship, correct? Okay, so that being said, let's talk about indirect proofs. So write these down. Step 1, Step 2, Step 3. Okay. So let's use an example with algebra to explain how we write indirect proofs. So our first step is assume the conclusion is false. Kind of like we did with the coffee example, right? Assume that you're not, what was it? If you are tardy, then you'll be marked late. So assume you're not late is how we did that, right? Okay, so the next step is show the assumption leads to a contradiction of the hypothesis. My third step is point out that because the false conclusion leads to an incorrect statement, the original conclusion must be true. All right, let's make sense of all that. So given 2x minus 3 is greater than 7, I must prove that x is greater than 5. So my first step that's the weirdest thing. Look it won't let me, oh, I hit the wrong one, sorry. My first step is step 1. I'm going to state that x is less than or equal to 5. Why did I pick less than or equal to 5? It's the contrapositive. If I'm saying x is greater than 5, then the contrapositive to that would be x is less than or equal to 5. Okay, so let's put that back into our equation. So my step 2 I'll fix that one later. My step 2 is to say that when substituting back in x, I want it to be less than or equal to 5. What's a number less than or equal to 5?
1.
5. Let's do 5 and see if it works. Less than or equal to, right? Push the envelope. Let's make it 5. 2 times 5 is 10. Minus 3 greater than 7. 10 minus 3 is 7. Is 7 greater than 7? No, that is a false statement. Therefore, step 3, right? Step 3 says, again, point out that because the false conclusion leads to an incorrect statement, the original conclusion must be true. So I'm going to say, because 7 is not greater than 7, the original conclusion must be true. What was the original conclusion? That x is greater than 5. We just proved something indirectly. Yes.
Why did you have to
Because in order to prove that x is greater than 5, I can do that by stating, well, if x has to be greater than 5, I'm just going to say it isn't. Find out if that's false, and if it is false, it must be true.
So why does it say one more? Why can't it just be greater?
Because this statement right here says x is greater than 5, right? So I have to say, if it's greater than 5, that means it couldn't be 5. Right? If x has to be greater than 5, we have to prove that x can't be 5. Okay, let's look at the next one. These, to me, make less sense than actually the geometric proofs. And you don't have to actually do the proof today. We just have to set it up, and that's why your homework is so easy. So let's do this together. State the assumption you would make to start an indirect proof of each statement. If I say AB is not equal to MN, what would be a false statement? AB is equal to MN.
That's it.
That's it. That's how you would begin the indirect proof. Triangle PQR is an isosceles triangle.
PQR is not.
James has got this. PQR is not an isosceles triangle. Isosceles. Did I spell it right? I'm always second-guessing myself. If 9 is a factor of n, then 3 is a factor of n.
9 is not a factor.
Good job. If 9 is not a factor of n, comma, then 3, you know what? This one's wrong. Think about it. If 9 is a factor of n, then 3 is a factor of n. So we would say 3 is not a factor of n. Does everybody see the difference? In order to prove that 3 is, we have to start by saying it's not and work backwards. Okay? Okay, let me explain myself again. This says if 9 is a factor of n, then 3 is a factor of n. That's like saying if you come to school late, you're going to be marked tardy. So in order to prove that this is correct, what we have to do is we have to just look at the Q statement. Take the Q, start with it, and say not Q. It is. Isn't that how you start a contrapositive? Look, this says if P, then Q. In order to start a contrapositive, I would have to say if not Q, then not P. Because if you said it's not a factor of 9, then it's not 3, then 3 is not a factor of n, that's the inverse, right? We can't prove the inverse. We have to start with Q and then prove not P, and therefore we know P then Q is true. Make sense? Okay, guys. Any more questions? No. I'll push this up.